Good afternoon, everyone. Thank you all for joining us today for MyDBOps My Webinar Edition 43. I'm Shiny from MyDBOps and I'll be your host for today's session. Today's topic is one that many of us in the open source database space have been looking forward to. What is new in MariaDB? Our speaker today is Monu Mahto from MyDBOps. Monu has hands-on experience working with MariaDB in real-world environments and is always up to date with the latest from the MariaDB ecosystem. Let's get started. Over to you, Monu.
Thanks, Saini, for the quick introduction. Good evening, everyone. Myself, Monu Mahto from Mydbops, going to speak about what's new in MariaDB with respect to latest advancement in MariaDB recent versions, improved performance, enhanced security, replication advancement, and latest well-known feature called vector search. Yeah, so this is about us. Like our organization, MyDBOps, has been founded in 2016, and we support database management and we provide a database consultancy services. We have assisted already more than 800 plus clients. Already, also we are a AWS partner and also PCI and ISO certified company. Yeah, so let's go through go through today's agenda. So first will be like MariaDB LTS release overview, enhancement to logical backup and restore, binary log and replication optimization, security features, and other some notable feature which has been released in recent versions, and advanced feature called vector in MariaDB. Yeah. So this is just a bar graph of MariaDB LTS release overview. So, like as you see, like I have taken all the LTS versions from 10.5 to 11.8. 10.5, it's already going to be reach end of life in 2025, this year itself after 2 months, and 10.6 after 1 year, and consecutively 10.11 for next 2 years, and 11.4 will be in ends in the coming 4 years. And 11.8 is the latest current long-term development series. So if you are in old LTS version, so you might have to consider for version upgrade or move at least to 10.11 or 11.4, so that you will be not so your server will be up to date versions. Yeah, so let's go through our first uh, topic, enhancement to logical backup and restore. Yeah, so from MariaDB 11.6, MariaDB has given an option called parallel logical backup in its MariaDB dump utility. So MariaDB dump is basically a client backup program utility which works with multi-thread MyDumper. I hope you are aware with MyDumper. MyDumper is basically open source tool which will support MySQL and MariaDB for taking a logical backup with multi-thread options. Like there we can use parallel options so that the backup will be fast, not like the traditional MySQL dump, which is like a single threaded version. So similar way, MariaDB also has this feature in MariaDB dump utility where you can use this parallel and hyphen directory option. So it will take a parallel and fast backup and with multi-thread option. So basically you have to consider parallel hyphen parallel, like how many thread you have to use based on your CPU core. So recommended is at least you can use the half of your CPU core on your VM or EC2 machine or whatever instance specification you have. So this is a sample command like MariaDB dump, MariaDB dump, and then username, password, and all database and directory where it has to store, and the parallel threads. Yeah. So as we have seen in the past slide, like we can use parallel option for taking the backup. So similar way, MariaDB import also has a parallel option to restore the files in parallel. Like parallelly, the threads can run, which can restore multiple files and reduce the backup restoration time in case of huge backups. So here also same way we have to define the directory and the parallel backup directory and the parallel option to load the backup parallel. So basically, these two features will if we have a data size longer, maybe huge data type like around hundreds of gigs of GBs, then in that case, this feature will help you to take a faster backup and faster restoration instead of going with other tools like MyDumper. Yeah. So also MariaDB import also have a feature called partial restoration. Suppose you have taken from a server entire backup all of with all database, but you want to just restore only few database or few tables. We have that scenario. Then in that case also this will work from your full database. If you give this possible options like database or ignore database or table, then you can only restore the required database or a table from the total backup. So this will help with your even if you have taken the full backup, but you want to restore only the partial backup or few tables or just or only a few database out of various database which you have taken in the full backup. But just we have to take care like you should have taken the backup with hyphen directory option only. Then only this feature will work for you. Yeah. So another option in the MariaDB dump is dump slave. So basically, it is like similar feature which the Maria backup has already. Maria backup has like a hyphen slave info. So it will have the positions of the master's bin log so that you can configure a new replica using that backup. So basically, this feature is available from MariaDB 11.6. It helps to create a new replica without taking a backup from the source. Like if you have already a master and slave, then the slave you can take a MariaDB dump using this option. Then it will have the position of the master. Using that, you can clone a new replica, create a new replica, or you can also do a point in time recovery. And also your backup will be, if you are using this option in your regular backup also, it will have a replication consider. Like any of your backup, you can use and configure the replication and set up under your master. It has default value as 1, which means it will print the change master command in the dump file. And if you go with the 2 like value 2, then it will adds this change master command in your dump file, but it will be not active. Similarly, if you remember, like there is an option called hyphen master data in your MySQL dump, so it will works in a similar fashion. So according to the need, you can use this option. Yeah. So this is like InnoDB optimize key in MariaDB import. So while you are loading your files with MariaDB import, and this feature is from latest version, that is 11.8. Uh, and while you're loading your data, like you have a huge tables or so, like a bigger size of table, then you are loading the data. In that case, having multiple secondary index can increase your data load time. So using this option, you can like already it's enabled by default, so that while doing the data loading process, a secondary index creation will be ignored, so that it will speed up your data loading process. Also, it supports only InnoDB tables enabled by default, but in case of huge tables where you have to like ignore like indexes, then it will work. But if you need an indexes, then in that case, you should use the skip InnoDB optimize key to disable it. Yeah. So now we move to our second topic, binary log and replication optimization. Yeah. So from MariaDB 11.4, they have introduced a variable called max binlog total size, which limits the total size of the binary log files on the disk, like how much binary log file combinedly can be stored on the server, on the wherever you have defined your binary log path. If the size exceeds that value, it will automatically remove the oldest file. Default is 0, which means there is no automatic limit for the total binary log files. And this you can define in like size in bytes, maybe that's depend on your workload, like 15 or 20 GB, which you want to keep like as a control, like this much binary log should be only there. It should not go beyond that as per your disk users percentage or free disks available. So in that case, this will helpful. Yeah. Also, like this variable is like limiting the size of a binary log based on size. There is another variable which we are already using, like expire log days, which will also purge the binary log based on the retention. So in case both the variables are configured, then together like they will manage the disk uses. But MariaDB will consider removing log based on both the condition, whichever has been met first. Like if first expire load logs days has came earlier than the total size, then it will start purging. So whatever size or age is condition met first, it will start purging the binary log based on that. So it is a global variable. You can use this set global statement and give the size, and you can set it. Slave connection needed for purge. So this variable also introduced in MariaDB 11.4. It controls like master binary log purging based on the connected replica. So suppose your master has one replica or two replica connected, and if this variable is defined, then it will verify whether that replica is connected or not. If it's connected, then only it will allow the binary logs to be purged. If it's not connected, then whatever the settings of max bin log size or the expire log days, it will not allow to purge the binary log. Default is 1, which means master will only purge the binary log if it's at least have one slave is currently connected. If it's not, then it will not purge any binary log. Yeah, as I have said, like if the number of connected slave is less than the value which we have defined for this variable, master will not automatically purge the binary log, even if the condition set by expire log days or the max bin log total size are met. If set 0, master purge the binary logs, regardless of connected slave. So this is also a global variable you can set using set global. Yeah, so this one is also an interesting feature to save the binary log file size, like binlog row image. So binlog row image, like earlier we have three options for it, like full, no blob, or minimal. But now they have introduced one more option for this variable, that is full no duplicate. In this, what it will have, like it will control how row-based binary logging including data in the binary log for replication. Like it will suppose you have, as you know, like when mostly people will use binlog row image is equal to full. So in that case, whatever before and after image, both will be saved in the binary log file. So if instead of using full, if you are using the full no duplicate, so before and after image, like whatever after image it will save in the binary log, that will only the return data, not the other columns or other fields which doesn't have any change. Only the change data of will be written in the after image. So in this way, it will be saving the space for the binary log file. So no duplicate unchanged column in after image. Smaller binary log size also, like it will save the IOPS, because it has less data, it has to write in the binary log. So it will save the IOPS and less redundant data in the return in the binary log, especially in the table with many columns, but only few are frequently updated. Yeah, as I mentioned, it works same as full, but while optimizing the storage, like as before and after image, only after image will have the change columns, not the exact all the columns which is in the before image. So it will save the IOPS and also avoiding the logging of unchanged column, that unchanged column values in the after image after any update or any insert or events has happened. So this is also globally like global variable. You can set it dynamically using set global binary log row image equal to full no duplicate. Slave about blocking timeout. So this variable has introduced in 11.7 recently, and it's a control like how much maximum time a replica DDL will wait for blocking a select or other user query until that query will be aborted. Like if you have set some timeout variable, suppose I'm giving an example like 20 minutes or maybe 600 seconds, so or 600 seconds, then it will that whatever like master has written some DDL that is replicating through the replica, and like it will and if some queries are running on the replica, some like analytics query which is blocking the DDL, so it will DDL will only wait for 300 or whatever 600 seconds I have set. After that, the replica will kill that select query which is blocking the DDL. So it will avoid the lags because of some select queries which is blocking the DDL. So MariaDB kills the log folding query after timeout and letting the DDL run. This variable especially helps in the scenarios where replication going to stall for indefinitely due to long running queries, especially on the analytics servers, where you see like complex queries are running for thousands of seconds. So, and it is blocking some DDL. Default value is like 3153600 which is close to 1 year. But you can set this value according to your like requirement and the need. Enhance replication status. So from MariaDB 11.6, like they have introduced few field in the source level status, which will help you to get the more consistent and detailed view of replication line. Before this, earlier, like what we are checking the replication lag by using the second behind master field in the source level status. But in some cases, like parallel replication, delayed replication, where in parallel application, various multiple worker threads are working, they are committing executing the transactions. So in that case, this value might be not exactly gives the exact lag replication lag. So in that case, this variable, these new fields will help. So there are these are the three new fields, like master last event time. It means like when the last event was read from the master. Slave last event time, it's like timestamp of the last event applied on the slave according to the master. So, and the master slave time difference is like a difference between like from first and difference of from both of them. Like difference of that like whatever difference we are getting, that is in the second. So that much replication second actually replication has the lag. If you see here, like I have given show replica status, this will be the values timestamp will be there, like when the last event has written on the master and when it has applied on the slave, and what is the difference between both of them. That is the actual lag. So this will give you the more consistent and detailed view of your actual replication lag. Instead of considering second behind master value, you can consider this value from this version. Now we will go through the security enhancement which happened in the recent MariaDB versions. Yeah. So first one will be like granular privilege visibility. So in this, MariaDB has introduced a new table from 11.4 version, that is privilege by table by level. So actually, this variable will give you the detailed, concise of privilege of each user on each table and which type of privilege they have. So that you can go through this table. It will have the consolidated view of table privilege considering different grant level. Also, this will help you like for auditing, like which user has which access on which table. So this will give you the consistent view. Also, sometimes it will help you to diagnose like why user might or might not have the access to a particular table or operation. So you can go to this table and you can go through this table and check it. And like it's like select star from sys privilege by table by level. This I have given one example where I am looking for a MyDBOps user, which privilege it has. So if you see here, like first table schema, table name, and the user and the privilege type and the level of grant, which has been given. So similar way you can use for your users. Audit plugin enhancement. Yeah. So from MariaDB 11.4.5, there is a enhancement in audit plugin of MariaDB. As you are aware, like in MariaDB offers a audit plugin and which can be used to audit capture all the operations happen on your DB. So this is a very useful feature. So earlier than this version, when audit logs are getting logged in the file, that time when we fire any create statement query with creating a user with this plugin, then that password will be not marked. It will be like a readable format. So that is a security concern. Like if the password is in readable format, so anybody can go to the like audit file and get the password. So that was a security concern which was fixed in this version. So after this version, if you run any create user using this plugin, then that password will be marked. So here I have given an example. Like I have created a MyDBOps user, and then I have if you see that same logs in the audit log, it is now marked. But earlier to this version, that password was not marked. So it was a security concern which has been fixed in the latest version. Information schema user table. So this also introduced in 11.5. So there is a new user table in information schema which will have the info like user detail, how many times it has the password error, like user has given the wrong password or some wrong credentials. So that will be captured, and also what is the exact password expiration time. So based on that, you can use this detail for your user management. Yeah, so we'll go through now other notable features which has been introduced in recent versions of MariaDB. Yeah, first one is temporary space users control. So basically, a few variables has been introduced to control the temporary uses, like max temp total space users. So basically, this variable will control the maximum total size of all the temporary files and the temporary table users over all over the connection, entire server. So if you have defined 20 GB of this value, so your all the connection will only use the 20 GB itself. If any user new connection has come and that 20 GB has reached, then that will get an error like there is global temporary space limit has exceeded. So basically, this variable protect the server from running out of disk. Like sometime you might have if you are running some complex query using joins or sorting, then in that case, sometimes you will feel like temporary table got filled, or you will go if your temporary table is in data directory, sometimes data directory got filled and MySQL become inaccessible. So to avoid those type of issues, this variable will help you. So you can define the total limit of the size, maybe a 1 GB or 5 GB for your temporary files and temporary table uses. And this is also global variable. You can set it globally. And the same way, there is another for the session level, max temp session space usage. So like this, you can specify for the particular connection or particular user, they can set this at session level so that their query will not use beyond this limit of a temporary table or temporary files. If it go beyond it, it will throw an error. So these two feature will help you to avoid access disk users because of this temporary file creations. Yeah, temporary space users control, InnoDB truncate temporary table space now. So basically, this is also one good feature which is introduced in MariaDB 11.3. This will help you to reclaim the space by the InnoDB temporary table space. Basically, it's IB temp one. So whenever you perform the queries or perform like a temporary table uses, sometimes it will increase the at times it will increase the IB temp one, and it is not getting free. So temporary table space can be shrunk by enabling this variable. Means it can be getting free. It can get the free, like whatever disk it has occupied. This operation only, just we have to note that this operation only reclaims the unused space. Doesn't affect your persistent data in the regular InnoDB table space. This variable, when it's get enabled, only truncate the InnoDB temporary table space, that is typically IB temp1 to free unused disk space from the temporary table. Earlier, for reclaiming this, we have to take a restart, but now you can do it globally. So you can set this enable, and whenever you see like IB temp has grown up, then you can free up by by enabling it globally. Yeah. So log slow. There is enhancement in the slow query logging, that is log slow always query time. This variable is introduced in 11.7. Basically, it's providing a mechanism to log all the slow query, irrespective of your long query time settings and other slow log filters. Like if your query time is taking more than this, whatever variable has defined, more than your value has defined, then it will log all the slow query, no matter of what. Query execution time longer than this variable will always be logged in the slow query, regardless of your other settings like long query time or log slow rate limit or log slow minimum examined row limit. So basically, this will helpful when you have to debug the slow queries, and this also supports till microseconds precision. So this will help you to log the even microseconds queries also. This is also you can use it globally, and you can enable and you can capture the slow queries. Yeah. Yeah. So now we go through our advanced feature of MariaDB, which has recently released in 11.7, that is called MariaDB Vector, or a vector search in MariaDB. Yeah. So first we will go through an introduction. What is vector? What is vector database? And then we will start like a vector in MariaDB. So what is vector? So basically, vector is like a numerical representation of data, whatever it's a text or it's a like audio format or it's like picture. So those things are converted into the numerical representation or the array of number by some AI embedding models or some embedding models. Then that is called like vector. So here I have given a example. I like MariaDB. So I have with using any embedding model, it will be converted into the like a vector. So that has been converted like values like 0.8, 0.1, or this type of vector. So like vector basically are like an array number or a list of number that represent things like text, image, or audio. Yeah. So now we'll go through understanding of a vector database. So as I mentioned, like text, audio, or pictures, any day unstructured data, if we are or like that has been converted by embedding models to a vector representation, and that vector will have that numerical representative that will be stored in the database, which supports the vector tables or vector data type. So like here I have given the MariaDB example. So it will be stored in the MariaDB, and in that the computations will be done. Like if you after you got like data has been stored in a database, you suppose your application has created a request which need to find a similar picture. So a picture in your database. So what it will do, first picture will get converted by the embedding modules. It can be ChatGPT or AI, OpenAI, any embedding modules that will convert into some vector number, a vector representation, and that vector will be searched in the database using vector index. And then the nearby or the similar vector, because basically in the vector indexing, they will use various distance function like cosine or Euclidean to search the data, to search the similar data. So that data will be searched and again given that vector representation again to the embedding models. Embedding models will again convert that to the your picture, and then you will get that nearby or the similar picture which you have searched for in your database. So basically this is a visual representation how vector database works. Yeah, so let's go through like what is vector database. So as I mentioned, a vector database that stores and serves the vector, which are just a list of numbers that represent things like text, image, or audio. Vector database are specialized database systems designed to efficiently store and query this vector embedding. Store this vector embedding is just storing that vector numerical representation data. And vectors are, if I talk to you about MariaDB relational database, vectors are stored in the binary format. And basically, what is the main role of storing this vector in the database is like to find the similarity or the similarity calculation, or like find the similar semantic search. So that can be done by two functions called cosine similarity and Euclidean distance. We will talk about both of them in detail in the further slides. Yeah. So the database in the vector database finds similar vector using mathematical distance like cosine similarity and Euclidean distance. So basically, Euclidean distance and cosine similarity defines how vector database finds similar things or similar vectors. So Euclidean distance is like you can consider as like distance between two vector, or like calculates the exact distance between two vector. And cosine similarity is like measure directional similarity or between similar vectors it will search. So if I give an example of Euclidean distance, like you can take it like how far two points are apart, or the example if I give like it's like a ruler which we use in our school as a ruler, it will give the distance between 2 points. Similar way, like if the even Euclidean distance, if the distance are smaller, vector are between 2 points, then vector are close, then both the vectors are closer, then it will give you that output. Similar way in cosine similarity, it is measured like how similar in the direction. They measure like the angle between the two vectors, not the distance, not their length. So like if I give you an example, suppose 2 points are there, though is that both the points are in the same direction. If two vector points in the same direction, it means cosine similarity is one. Cosine similarity is basically the best way to like find the similar things or the similarity between the, it can be any data, it can be image or audio, anything. So it will not give you the exact similar thing, but the nearby similar thing. Yeah. So now let's go ahead. Vector in MariaDB. So vector in MariaDB was introduced in the recent version, that is 11.7. MariaDB vector is a feature that allows MariaDB server to perform as a relational vector database. So it can store the vector data and query the vector data. So vector are generated by any AI models can be stored and searched for the in the MariaDB. And MariaDB use from initial implementation of vector, it used the HNSW algorithm. Basically, this is if I if I define, like, this is a very popular algorithm to solve the problem where called to solve a AN problem, like approximate near neighbor problem. So basically, what is HNSW? We will go through in detail and AN problem in detail in our upcoming slides also. But let me explain you what is HNSW. Basically, it's a hierarchical navigable small world. Means it's a very smart algorithm in the vector database to quickly find the nearest neighbor, most similar vectors between like millions of vectors. And it's a super, if I say, it's like an efficient way to search a similar vector in a millions of vectors. Uh, like suppose like if like you got a vector and you have a millions of vector in your database, now you have to search that similar vector to in that million of vector, what are the other vector which is similar to that vector. So for that, if you go with the traditional way, it is like linear search. You have to go one by one and compare with each vector. So that is gonna lot of time, and that is not gonna work in the real world. So in that case, HNSW will help. Like what it will do, it will organize the vector in the smart layer graph. So you only need to check the few nearby neighbors. So if I give an example of an HNSW, like how it works, let's suppose you went in a very big or famous city and you have to find the nearest coffee shop. So what you will do, either you can go around all the city and check every place where is the coffee shop, or else you can ask some nearby people like where is the coffee shop, or you can ask your neighborhood like where is the coffee shop. So that second approach will give you the answer faster way, because you have asked them and they have told you, oh, there is a coffee shop, so you can go there and have your coffee. So in this, if in the similar context, HNSW build a networks of shortcuts among the vectors, so you can navigate the search through the you can navigate your search through the nearby vectors, and you can get the similar result. And if I talk about SNF in more detail, it's like a multi-layer graph, and it will during the search, first it will go to its top layer, then it will go to our closest node, and then it will go below to drop down, and it will check again the best candidate for your search which has matched, and it will try to repeat it again, and at the end it will find the best suitable vector candidate. Yeah. Yeah, so as I explained, like HNSW stands for Hierarchical Navigable Small World. HNSW is a algorithm in the vector database to find the quickest neighbor, like nearest neighbor. So basically, it's a very efficient way to search a vector in the millions of vector within a millisecond. It's a very powerful and popular algorithm for the solving AN problem. So basically, if I explain what is AN problem. So AN problem, like suppose you have a huge set of vector, like 1 million vector. You have a database or a table where you have 1 million vector, and you have to find one most similar given vector. So in that case, what it's like, you don't need to find the exact same vector. If you can search exactly the nearby or the enough like closer to that vector, that is also fine for you. So that is the AN problem. And that using that HNSW, you can solve this AN problem. And by default, like Euclidean distance function is used as a default. So in the further slide, we will talk about this Euclidean distance and cosine similarity in detail, and how they are used in the MariaDB functions. Yeah. So like vector data type in MariaDB. So vector data type were introduced in 11.7.1. Vector data type was added as a part of vectors feature, like which permits MariaDB to perform as a relational vector database. So by defining this data type in the create table statement, you can store the vectors in your table. And n in this syntax means like it's a like integer specifying the dimensionality of the vector, like number of elements in the numerical array. Vector data type basically stores in the fixed length of array of 32-bit. It's a standardized set. which is a standard floating point number which has been set by international standards, and it will store this 32-bit IEEE 755 floating point number. It's a native data type. So in MariaDB, you can use SQL, standard SQL to create a table and insert the vector data. Let's go through the vector table creation. So MariaDB has a like dedicated vector and data type which with a built-in data validation. Example, if you fire a create table, I have just given an example, create table embedding. I have given here ID column, and then I have given second column as embedding, which is a vector data type, and in bracket I have given 1536, which defines the dimensions. So in this way, you can create a vector like table using vector data type. And just one more thing, like vector data stored in binary format. So if you want to read that data, you can't read it. It will be in the binary format. That also we'll see in the further slide. Yeah, so here I have created one vector table. If you can see here, like embedding is a column and vector is its data type. Yeah, so we'll go through the vector index. So basically, as you are like, indexing is a feature which can help you to do the faster lookup. In MySQL or MariaDB, we already have the primary key, secondary index, or unique key to faster up the lookup, or like to search any data in throughout the table now faster and enhanced way. Similarly, vector index also have this. Like vector also have this feature, and it's called as a vector index, and MariaDB also provide this supports this vector index. So to efficiently search vector data, MariaDB provides a specialized vector index, and basically this vector index using some functions in the backend, that is basically Euclidean distance or cosine. So the distance function is used to build, and these functions are used to build the index. So basically, if the index has been created on the vector data type or the vector column, so which function it will use to sort or to search the vectors in the table. So which indexing function will be used, like either it's Euclidean or cosine, that defined by the there is a variable in the variable that defines that which will be used by default, and default will be Euclidean. And but if you want to change the cosine, you can either change that variable. We will in the further slide we will discuss about that variable, or else you can specify while creating the index. So basically, vector index can be created specifying cosine or like Euclidean. But if you don't specify any function, it will use Euclidean function. Yeah. So, and one more thing, currently, like vector supports only one index in a table. Like if you have a table where you have a vector data type column, so only one index you can add. You can't add more index. If you try to add more index on the same column, you will get an error, which I have shown, which I have like added here. Like the version of mine doesn't support multiple vector index. Yeah. So this is a one example where I have tried to add a index on the vector column. So I have run an alter query to add a column in this embedding table. So if you see, like I have used this embedding column, embedding VC IDX. So it has added the vector key here. If you see in the table structure, and I didn't mention specified any function which it has to use. Either it has to use Euclidean or cosine, but it has used Euclidean as a default, because that is a default distance function used by the MariaDB. Even but if you want to create a cosine, because sometimes because in some search you need to use cosine, because in very when your data is like image or some audio data, or some where you need to search the where you need to more focus on the semantic similar search, where you need to search the similar thing. In that case, cosine function will be used. So here I have run the same alter query. Just at the end, I have defined the distance equal to cosine. So if you see here, it has created a vector key with the distance cosine. Yeah. So now we'll discuss about vector distance function in the MariaDB. So as I mentioned earlier, there are two. There are like two distance function, Euclidean and cosine. So basically, as I've explained earlier, like Euclidean is like how much distance between two vector, and cosine similarity morely focus in like how similar in the direction, or how much similar they are between two vectors. So here we will go through all the like vector distance functions. like there are basically 5 functions that currently supports in the MariaDB. So first is like vector distance Euclidean. So basically, like what it does, like it's a function that calculates, it's a SQL function that calculates the Euclidean distance between 2 points or two vectors. Similar way, vector distance cosine, it's a SQL function that calculates the cosine distance between two vectors, like how much similar they are. And there is a generic function called vector distance, which will use to it will be it will be used to define the distance function based on the index it has, like how the index has created, that will be used by, if you use this function, that will be used, that distance function. Yeah, so there is a another function called vector from text. So basically, it will convert a text representation of vector into a vector data type. So here I have given vector from text and I've given some values. Then it has converted to the vector data type. Yeah, and similar way, there is a vector to text. So yeah, so vector to text. So this will converts a binary vector into a JSON of array. Like here I have given one binary vector that it has converted into the array format, if you see here. Yeah. So now, like there are, as I mentioned earlier, there are various variables in the MariaDB which controls this vector indexing. So first one is MHNSW default distance. So basically, MNHSW is memory based hierarchical navigable small world. So it's the algorithm which we have defined earlier, like how this algorithm helps to solve the AN problem. So based on that only, it has defined the various variable, and that will define, that will decide how the indexing will be used. So this is a variable which specify like which default distance metric will be used. Either it will be Euclidean or is a cosine, which will be used. So that defined by this variable, and it is used when distance option is not given while creating the index. So whatever you have defined in this variable, so if you are not defining any distance option in while running while creating an index on the vector column, then it will use this variable distance function. So you can set it, it's a global variable, you can set it like set global MHNSW default distance equal to Euclidean or either cosine, and that will be used for the like adding a distance function index of the vector data type. So basically Euclidean and cosine. So where we have to use which one? So if your data is like spatial or geographical stats data, then you can use Euclidean, or if you have an image, you can consider using Euclidean. But if you have a text or semantic search you have to do, then in that case you have to use cosine. So based on your data, you can choose which distance function you can use. Second variable is MHNSW default default m, like basically this default m parameter, like it's defined in the while we are adding the vector indexing. So m parameter controls the number of connection per layer in the graph structure of index. So basically, if we have a larger when we are defining the index while running the alter, you can define this value m as a between range between 3 to 200, and 6 is default. So basically, if you have a large value of m, it means better the search accuracy, but large index will be created. And if large index will be created, the incoming vector data in that table will be slower. Similarly, if you have a smaller m value, then faster updates and search will be faster because the index size will be smaller, but it will give you the potentially less accurate search. So based on your need, you can choose this value, and default is 6. Yeah. Now EF search. So basically, this variable will define the number of results in the vector index for order by limit and query. So when you are running a order by limit and query using to do a vector search, in that case, like irrespective of your limit and values, it will use that particular this variable numbers to do the search, so that it can improve the search quality. So if you have defined some variable, some value for this variable, the server will never search less than the rows that even if the smaller limit is given. Even smaller limit is given, it will always search this many number of settings which we have given to this variable to give you the proper to give you the quality of search or the accuracy of the search. So this improves the search quality at low limit values, but high values increases the search quality, but it will impact the query performance. So similar way, lower values can lead faster execution, but what will happen, it will it might miss some nearest neighbors. So we have to use this value according to our requirement, and especially when limit is small and data distribution is complex. So based on that, you can consider using the variable, and default is 20, and its range will lying between 1 to 1000. So based on your how much you want to how your order by query limit, with some limit you want to search in the backend, like how much it search it should do, how much vector it should search. So based on your requirement, you can give this number. And max cache size, like basically this variable controls the vector index cache, controls the amount of memory used for catching the index. And basically the this variable manage the maximum amount of RAM or the memory can be used to catch the graph structure of the individual vector index. Default is 16 MB, but you can increase as per your consideration and as per your requirement, and this is can be done globally. And also we should give these values in limit so that it can avoid the over memory utilization. Now we will go through the vector search example. So here I've created one table called vector store, and I've inserted few records. And then going in the further slides, we will do some we will fire the vector queries to do the vector search. Yeah, so I have just tried to search from that table. So you can see it's showing a binary data. You can't read it. It's a it's stored in a binary format. So if you want to read that data, then you have to use this function vat to text. So now I have used this function for this column. So now if you can see, like it is giving the vector for the particular name. It's a map with the vector. Now it's anyway readable, but in earlier it was not readable. So we have to use this vat to text function to get the data in readable format. Now we will do the vector search using different function which we have earlier which we have gone through earlier. Like first we'll go with vector distance Euclidean. So basically it will use the Euclidean distance function to search the given vector. So I have fired this query with the order by, and I am trying to search this vector from the this table. So I have run this query. So first it's tried to match with this vector. It got the match with banana. So banana at the top, and other nearby values are given as per the semantic search. So similar way, I have run the same query again with the vector distance quotient. Here also the matched vector will be given, and the consequence and the adjacent similar values will be given. So in this way, you can use these functions to do the vector search. Yeah. So I think that's all from today webinar presentation. Let me know if you have any queries or anything. So please drop your queries in the comment. We will respond it as soon as possible. Yeah, these are the some references which I have used to prepare this presentation. Yeah, and thank you everyone.
Thank you so much, Monu, for that wonderful session and for walking us through all the exciting updates in MariaDB. It's always inspiring to see how MariaDB and open source tech keep growing. To everyone who joined us today, a big thank you for being here. We truly hope that this session gave you some valuable takeaways and helps you in your work with MariaDB. And for those who are new to us, we are Mydbops, a team that has been around since 2016. We have had the chance to support over 800 happy customers with database consulting and managed services. And we work with a wide range of databases: MySQL, MariaDB, MongoDB, Postgres, TiDB, Cassandra. And we are all about making database management simpler, faster, and better for our clients. We also believe in giving back to the community, so these webinars are one of the ways we share our knowledge, experiences, and learn together. If you found this session useful, Please subscribe to our YouTube channel for more database content. Follow us on LinkedIn to stay updated with our latest blogs, services, and events. If you have any further questions or require additional information, feel free to reach out to us at info@mydbops.com or visit our website mydbops.com. We will also be sharing the webinar recording in the upcoming week, so stay tuned for that. And our next webinar will be all about MongoDB. Stay tuned for more details as well. Thanks again for being a part of MyDBOps My Webinar Edition 43. We will catch you in the next one. Thank you.